We're going to look at a couple cone problems now. Water is flowing into a cone at a rate of 2 centimeters cubed per minute. So this tells us we're dealing with volume. The cone has a height of 16 centimeters and a radius of 4 centimeters. How fast is the water level rising when it's 10 centimeters deep? Okay. So these are a little different. So I'm going to draw my cone. You can draw it whichever way you want. If you have it flipped around, that's fine. Okay. Now, even though 16 and 4 don't come after the word when, we're not going to put them into the picture just yet. Okay, so here's my radius, here's my height. Okay, what we do with the cone problems. Okay, so before I do this, our equation for volume of a cone is going to be 1/3 pi r squared h. So when we go to do the derivative, we would have to do product rule, and we would get a dr dt and a dh dt. We'll see they only give us one rate, so we would have too many dt's and not enough information. So for every single cone problem, what you're going to do is set up a proportion. So you're going to do r over h. So this is where we're going to use these numbers. Okay, so remember this 10 centimeters, since it comes after the word when, we're not going to use this until we plug it into the derivative. Okay, so these are going to be the two we use for the proportion. So that'll be 4 over 16, and then you want to reduce it. Okay. And then from here, what we want to do is solve for h. So I'm just going to multiply through by h, so this will cancel. So what we get is r equals 1/4 h. Okay. So then we're going to take this, and we're going to plug it in for r and simplify. Okay, that way our equation will just have an h in it. Okay, so that way we'll only have one dh dt. And the reason we're keeping h in it is because they told us how deep it was. That's the height. Okay, so we're always going to solve for r, plug it in terms of h, and our final equation should just have an h in it. So this is going to end up being 1/3 pi times, this will be 1/4 squared is 16, then h squared times h. And then your very last step would be to simplify. So 1/3 times 1/16 is 148 pi h cubed. Okay. So the cone problems, it'll always be set up a proportion, always do r over h, solve for r, plug it in, square it, and then simplify. Okay. And then from here, we can take our derivative. Okay, we no longer have to do product rule. Okay. So the derivative of v will be dv dt equals, you're going to do 3 times 1/48, which will give me 1/16 pi h squared dh dt. Then I can go ahead and plug everything in. We're looking for how fast the water level is rising. That's our dh dt. So I'm going to plug in a 2 for dv dt. It's positive because we're putting water into the cone, so the water level is increasing. And then that'll be 1/16 pi. Your h is 10 dh dt. So I'm going to go ahead and do 1/16 times 10 squared, and that's going to give me 2 equals, that'll be 25 over 4 pi dh dt, and then I'm just going to divide by 25 pi. So you could simplify this. You could divide these and just leave the pi on the bottom. But usually when it's something weird like that, I don't leave it in terms of pi. I'm just going to type it in on the calculator. So I'm going to use the fraction and just type in 2 divided by 25 over 4 pi. and that'll give me 0.102. So dH dt will be 0.102, and it's just going to be regular centimeters because we're dealing with the height per minute. Now let's work through one more of these. A water tank has the shape of an inverted cone, so that just means an upside down cone like what we drew. I always draw mine like this. A water tank has the shape of an inverted cone with a base radius of 2 meters and a height of 4 meters. If water is being drained from the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 feet deep. So we've got our radius and our height. Okay. For every single cone problem, I'm going to set up a proportion. So R over H, the radius is 2, the height is 4, so that'll be 2 over 4, which reduces to 1/2. Okay, so I just went ahead and took that 2 over 4 and reduced it. Okay, and then you're always going to solve for R, so multiply by H, and you're going to get R equals 1/2 H. Then we're going to use that for our equation. So volume is 1/3 pi. Instead of R, I'm going to plug in 1/2 H squared times H. Okay. Then we're going to simplify. Okay. So when I square this, that's going to give me 1/4. Okay. Well, 1/4 times the 1/3 will be 1/12. H squared times H will be H cubed. Okay. So you're always going to end up with an H cubed here. It's just the coefficient that will end up being different from problem to problem. So it's always going to be this number squared times the 1/3. Then your derivative. The derivative of v is dv dt. 3 times 1/12 pi is just 1/4 pi. This will now be an h squared with a dh dt. This I know is my dv dt because it's volume, because it's got the cubed, and since it's being drained from the tank, that's going to make it negative. So I'll plug in a -2 for my dv dt. They told us the height, that's how deep it is 3. So that'll be 3 squared dh dt. So we'll have -2 equals 9/4 pi dh dt. That's just the 1/4 times 3 squared. And then I'm just going to type in my calculator to get dh dt. That'll be -2 divided by 9/4 pi, which will give us about -0.283 meters per minute. It's meters because we're dealing with height.